Hello everyone. So welcome to another Leetcode question, and in this question we will be solving merging two sorted linked lists. So what we have is the head of one linked list and the head of another linked list, and it is given to us that these two linked lists are sorted and we have to merge this linked list in one list, right? So, and one of the conditions that has been given to us is that the resulting list should be made by modifying or splicing together the nodes of the first two lists. So basically we are not creating any new list, we are just alternating or modifying the nodes of the previous two lists in order to get the resulting linked list. And what we are returning here is the head of the merged linked list. So this is the question. Now let's go through one example at least to understand what the question is asking. So what we have is, let's say our first list is this and our second list is this, right? So in the first list we are given, and L1 is actually the head of the linked list, right? So in the first linked list we have 1, 2 and 4, and the second linked list we have 1, 3 and 4. So we can see that these two linked lists are sorted. Now the resulting linked list would look like this. So let's call it R, and when we return R we are simply returning the head of the resulting linked list. So 1, 2 and 4, these one has come here, these two has come here, and this 4 has come here, right? So for the L2, its 1 has come here, its 3 has come here, and its 4 has come here, right? So actually this list is actually a result of these two lists, right? And then we have to return the head of this list. The thing that we have to notice here is that we are not creating a new list. We are not creating a new list. We are just we have to modify this list only to get the final list. So this is the input, right? 1, 2, 4 and 1, 3, 4, and this what the resulting list would look like. Now let's discuss the intuition behind this. So let's imagine that this is RL is the resulting list. So what we can say is that this will be some function between L1 and L2, and what we have to do is, if the first node of the linked list L1, the value of that node is lesser than the value of the first node in the linked list 2, then we will take the first node of the linked list 1, right? Because that should come first in the sorted order, and then we'll process the rest of the linked list L1 after the node first, and the L2 everything of the L2, right? So here we can see that if it is not the case, if the first node of the L1, its value in this case it will be greater than the first node of the L2, and in that case we will take the first node and will process the rest of the nodes other than the first node in the L2 with L1, right? So we have to do something like that in order to get our resulting linked list, right? So this is majorly just an intuition behind it to approach the problem. Now let's discuss the optimized solution for this, right? So what we have here is that we have a L1 which is pointing to the head of the first linked list, and L2 which is pointing to the head of the second linked list, and we will get a resulting linked list like this. This is something that we have already discussed. So one more node here will be 100, and then this is the null. So this is what the result of it would look like. Let's think about this for a moment. So if what we can do here is that we'll keep a previous pointer, we will actually create a new node. This is just a temporary node with value 0, and its next pointer is pointing to null, right? So its next pointer is pointing to null. Now we are at L1 and L2. So we know that if L1 value is less than equal to L2 value, L2 is here, L1 is here. So what we can do, the next of it, previous next, would point to this guy. Okay, and then we can move L1 forward, right? Because L1 value is less than equal to L2 value, so L1 will come here. Now previous has to be pointing to the node that we just processed and we saw that its value was actually the lesser of the two nodes that we compared, right? So that every time we need to update its pointer, its next will always point to the correct one. Now we are here, we can see that L2 value 1 is actually less than L1 value. So previous next, this will get removed and we can move this guy to this, right? So this pointer will update to L2 and L2 can move forward and then previous will come here, right? Now in this case, this is very interesting. So L2 value is less than L1 value, right? So previous next has to point to L2, which is correct. Previous next is pointing to L2 and L2 will move forward and then previous can move forward, right? Again, which one between the L1 and L2 is smaller? L2 is smaller. So what we can do is previous next will point to L2, right? We have to correct the pointer of the previous node which was in the process that we compared between the two values, right? So in this case L2 value is less than this, so previous dot next is L2 and what we can do is L2 will move forward and then we have to update previous the last node that we just checked, right? So 3 is now done, 2 is now done, 1 is now done and this one is now done. Now between these two L1 value is actually less than L2 value. So this next pointer we have to update it to L1, right? So previous dot next will point to L1, L1 will move forward, and then previous have to be updated to this guy, right? And then what's remaining of us is here between L1 and L2, L1 value is less than equal to L2 value. So this is pointing to L2, previous next is pointing to L2, then L2 will move to null, L1 will move to null, right? We have to update each node to the next value and then previous will move to the forward, will move one node forward previous. Now any of the time whenever the L1 or L2 reaches the null value, then we'll come out of the loop. So if we write this guy here, what it would become is like from 0 to we went to 1, from 1 we go to this one, then from this one we went to 2. We are just following the blue pointers, right? 2 and then 3 and then we went to 8, from 8 we went to 9 and now we are here. My previous is pointing to this 9, the last node that we checked between L1 and L2, and we have a null, right? So once the loop is over or once we came out of it, we know that only one of the pointer is not null and one is null. So the next of previous will be updated to the one which is not null. In this case L1 is null, so we'll update previous dot next to the L2 and L2 is at 100. So this will point to 100 and anything after that in the L2. And this order will always be sorted. Why? Because L2 is sorted, right? And so now we need to return the head of it. How will we return the head of it? What we can do is, now previous is pointing to this, so using previous we cannot return the head of it. So we can create another pointer at start only at the beginning, and this node will be pointing to this node. And simply what we'll do, we'll return phead dot next, which is this node, and then our algorithm will work exactly how we want it to be. Let's discuss the time and space complexity for this. So at any case, or in the worst case, we'll be going through the entire length of the L1 and the entire length of L2 to modify the nodes and return the sorted list. So in that case, the time complexity will be the length of L1 plus the length of L2. And space complexity will be constant because we are not creating any auxiliary space in between this. We are just modifying the already existing to list. Okay. Now let's go through the code walkthrough for this. So like we said, we have a list node L1 and L2 point to the head of their respective list. we created a temporary node p head, which is pointing to just a temporary node, and its next pointer is pointing to null. Before that, just wanted to discuss the class structure of the list node. A list node will have a value, a next pointer, and there are three constructors here. One is an empty constructor. It is given to us in the question. We'll see it later. This has a value that it is assigned to the value property of the class, the value and the next pointer, right? So we are using this constructor, right? In this case, the next pointer will be null. So p head is constructed like this. Then we have a priv, which is also pointing to this guy. This is p head and priv. Like we said, while either of the node is not null, if any of the node L1 or L2 has reached to null, will break, right? Then we said, like, if both of them are not null, then in that case L1 and L2 is there, right? So we checked if L1 is smaller, then we said we'll update the previous pointer is next to L1 and we'll move L1 by 1, right? So if we had something like this, point null, this is 1, this is 2. Let's imagine we were something like this. Now L1 value is less than equal to L2 value. It is correct. Yes, so previous dot next. This will remove. Previous dot next is L1. And L1 will move to the next one. L1 was here. L1 will move to the next one. And then we have to update our previous to its next pointer. So that our previous is always at the right point, which was last process between L1 and L2. Right? So otherwise, in the other case, we can, this is the same as the above case, but for the L2, and otherwise we'll update the previous case. And the last case that we discussed is that if any of the list, one of the list has to be null at the end of this loop. Let's say when L1 is null, then we'll update just the next pointer of previous to point it to L2. Otherwise, we'll point the next pointer of previous to L1, right? So this is the case. Let's just go through this once. So this is pointing to some list like this, and let's say we reach the null of this guy, and we had another list which was in process, continuously builded in between. Then if let's say this list, some of the nodes of this list is remaining, then if previous was here and L1 is null, L1 reached to null, so what we can do, we can simply update this pointer to previous dot next to L2, and everything will be in sequence for this p head, which is just the previous of the head of the resulting list, right? So we can return p head dot next. So this is the head of the resulting list. Basically, this head is equal to p head dot next, and we are returning this from the loop. This concludes our 6th question, merging two sorted linked lists together. Thank you.